Okay, we're going to talk about this problem a couple different ways. First, just remember what you really know about, y equals mx plus b. So your slope and your y-intercept here. So hopefully you can see that your slope is definitely positive. The number in front of x is your m value. That's your slope. And it's 5.6. So I think this answer and this answer are out. Those are both negative slopes. And then I'm not sure if you're paying attention, but this seems a little wonky. I don't really do this much in my class, but did you notice there's like a little separation there? It's got a little jagged line. It's the same thing actually on the vertical axis here from 320. It doesn't actually show every step from 320 to 0. Same thing from 60 to 0. It just kind of skips from 60 to 0 there on the graph. So it's not really showing you the true y-intercept. You can't just eyeball it and go, oh, it looks like it's at 0, or it looks like it's at 500 or 600 here. So that's what I think makes this problem a little bit tougher here. So there's different ways to do this. One would be to plug in a value, like for example, if you plugged in 70 for our x value, you would expect, if this is the graph, to get somewhere around 70 or 60. Whereas if you plug in x is 70 here, you would expect to get around 700. So that's a big difference. This ordered pair is 70, 70 or something close to that. And this ordered pair is 70, 720. So I think if we plugged in 70 here, so let's just kind of do that. So if you have a calculator, we could type in 5.6 times 70. And then subtract 324 from that. So it looks like it's going to be around 70. It turns out it's about 68 there. So this answer must be, I believe that answer must be correct. There's another way to do this. We could do this on a calculator. And I want you to show you this so you can adjust your window. Maybe you haven't done that very much. It's definitely something you can do. So I'm going to go to a graphing page here. So it's a home key. I'm going to just graph negative 324 plus 5.6x, and I can't see it at all. So one way to see it is to go menu, window zoom, zoom out. And so we're going to zoom out a number of times here. I'm just going to keep clicking until I can kind of see the function. And so you could adjust it and maybe get it that way. I still can't see, I can only see up to 400. There, I'm finally up to, maybe I could trace it. For example, so now I could go menu 1. I could type in 70 in trace mode, and it jumps to the point 58. And so I know it's A rather than B there. But another thing you could do is just kind of change the end values here. So if you hit escape and double click and change this end value to 100, because I want that to be just like the picture here. I'm going to tab over to this one down here and change that to, say, you could change it to 0, but since I know the y-intercept's negative 324, I'm going to make it negative 500. I'm going to make this one 0. And then I'm going to make this one 250, 900, maybe 1,000. So there is your graph and maybe it would make more sense to make this like, negative 50 or something, just so we could see the axis. Oops, so I have to change. So that one is negative 500. Make that one negative 50. I can see the axis a little better. You can see that, I just like to be able to see the axis. You can see that every vertical tick mark is 100 units, every horizontal tick mark is 5 units. So you can see that the y-intercept looks to be about negative 300 something, whereas, but if we want to change it to look like this, where does it actually hit if the x value was 60? So we could make this one 60. This might be interesting. So now this is what the pictures look like as far as, at 60, it looks to hit very close to what is essentially a 0 value here. Kind of like this one does. You see how that hits right there at very close to 0 at 60, whereas at 60 here, it's hitting up there near 600 or 700. Clearly on the graph, it's not hitting up 600 or 700. So if you change your end value to look like that. Another way to change the end values is menu window zoom. We go to Windows settings. You can actually change them all in there. So Xmin, Xmax. So 60 to 100 was our X values. And I went negative 500. You could just make it, if you'd rather just make it 0 there, 1,000, kind of like those are, you can make it that way as well. And it should give you a good idea of what the graph might look like. If I change this one from 1,000 to what it is on the correct answer there, maybe 250. Now it looks almost exactly like that part A graph. When I change the scale to be like that, it should kind of look like that. So it's just a different way to go. I just want to show you how to use your window, change your window if you needed to look at the graph a different way. Here's number 2, another graphing one. So the circle has a center at -1, line is tangent. I don't know if you remember this, but whenever you have a tangent line, this forms a 90-degree angle there. So right there with that point of tangency, it could hit 90 degrees. Which of the following points also lie on line T? So now that I have line T, so if you can figure out the slope between these 2 points, right? So the slope formula is y2 minus y1. So 1 minus -3 over -1 minus 4. So I get 4 over -5. I get -4/5. That's for the original slope. That's the slope of this blue line. If I want the slope of this other line here, so this line T, if you remember, so the slope of the perpendicular is the opposite reciprocal, so that would be 5 over 4. That's positive instead of negative there. So 5 over 4. And so the slope of this line is 5/4. And so you could do a couple of things. You could actually go up 5 over 4. So if I go up 5, that would put me at a y value of 2. Over 4 to the right, that would put me at an x value of 8. There we are, just by checking 1 point. Another way is to write the equation for that line. So you could type in, you should go y minus y1. So I could take this point right here. So y minus -3 equals m, which is 5/4, times x minus 4, which is your x value. That's your x and that's your y. Actually, your x1, your y1, essentially. We're plugging that in for m. And so we have this equation here. And so you could graph this guy in your calculator. It's another way to go. So you could graph, I'm just going to solve it for y just because it's pretty easy. 5/4 x minus 4. And I'm just going to subtract 3 from the other side. So another way to go here is you could actually graph. Look at we graphed out a regular kind of window there. 5/4 x minus 4 minus 3. Oops. X minus 4 minus 3. And so there's the graph of that line, and you could trace, if you wanted to, then you find 1 and then an 8, and you see that that point is on there. 8, 2 is one of the points. If you trace the 9, you can see it's supposed to be 3.25. Not 1 there, and you can check some of those other values and see why they don't work if you want it. You can also hit Control T, gives you the table, so you can just scroll through until you find the point you need. That would be T. This is the point you wanted there. So this one, C is a constant, so we don't know what the value C is. The equation has 2 distinct real solutions. Which statement must be true about the value? I don't know if you remember this formula. It's the quadratic formula. X equals opposite of B plus or minus square root all over 2a. And inside of there is something called the discriminant, b squared minus 4ac. And I want 2 distinct real solutions, which means my discriminant, my b squared minus 4ac, has to be positive. Remember that theorem from earlier in the year. And so if I plugged in b is 6, a is 1, and c is the c. So this would be 36 minus 4 times 1 times b is greater than 0. So I get 36 minus 4c is greater than 0. So 36 is greater than 4c. So I added c to both sides. Divide by 4, divide by 4. I get 9 is greater than c, or c is less than 9. And so I get my answer algebraically. I do it that way. I think you could do this in the calculator. You could check some values. One way of doing this is, it's kind of neat that it does this if you've never seen this. You can actually type in a quadratic here, x squared. I'm just going to type it in plus 6x. Let's say plus c and see what happens. Have you ever seen this? Create a slider. Okay, I've created a slider. And so the way the slider works is you can actually grab this and move it and change the value of c. And you can see as I get like up to 5, it's getting closer. I want to have all these have more than 2. So negative 5 has 2 solutions. Positive 5 has 2 solutions. Everything in between has 2 solutions because it's crossing the x-axis at 2 values there. So I know it's not just this one. I know it's not just greater than 9. I know it's not just 6. Really, you know it's d. Just you didn't have to change the scale on that. You could, I think, change that to make it include like the numbers for different things. Now, if I go bigger than 9, like the 10, you can see at 10, c is 10, it doesn't have any solutions. It doesn't cross the x-axis. Just another way to show it to you visually what's happening there. It's really neat if you remember the discriminant method there. So each greater than 0 and 4 times the square root of a is equal to 9. So let me write that. 4 times the square root of a is equal to 9 times the cube root of b. A equals 2/3. What is the value for a, which a of x equals b? Wow, that's a lot. Okay, so a lot of different ways of trying to solve this. You could, so we know a is 2/3, right? So 4 times the square root of 2/3 equals 9 times the cube root of b. But this is not kind of what we call kind of normal math here. Like we have not seen a whole lot of problems like this in Algebra 2. It's a different kind of problem that we're not used. I guess we could type in that into our calculator. 4 times square root of 2/3. That would be. We could also simplify it. I'm going to multiply by square root of 3 over square root of 3. So if I do that, I get 4 times square root of 6 in the numerator here, and I get 3 in the denominator. And that, I don't know if that's really much better. 9 times. You could also write b to the 1/3 power if that made more sense. I'm going to divide by 9 here. This is going to divide by 9 here. Boy, that's still kind of weird here. So we have 4 square root of 6 over 27 equals b to the 1/3. I guess you could cube both sides. And get that answer. So that would be, wow, let's just type that in and see what that is. And you can actually type that in and it'll give you the correct answer. Okay, let's go on. Okay, I'm going to calculator page. And 4 square root of 6 over 27, all to the 3rd power. Wow, so we get that, right? So it's not very nice for sure. So we want that to be equal to a to the x, or 2/3 to the, so we now have, you know, that whole monstrosity there. We have 128 square root of 6 over 6,561 equals 2/3, because that's what a is, to the power of x. So 2/3 to the what power is that? Well, you could use logarithms at this point, right? We could write this as log base 2/3 of that big number, 128 squared 6 over 6561 equals x. There must be an easier way to solve this. I'm just guessing. Wow, this is a lot. Log of 2/3 of that. Wow, that's really helpful, isn't it? Let's see what the decimal is. All right, control enter. 7.5. 7.5 after all that. You get 7.5. So there might be an easier way. So how could we solve this? We could solve this one for B. So your calculator does have a solve command in there. So menu algebra. This would be a good example of a problem that you could use the solve command. So 4 times the square root of 2/3 equals 9 times the cube root. So I like to take this cube, get the cube root of B. And then you have to put outside the inside the parentheses, but after the equation, comma, the variable you're solving for, which is B. And it gives you that same answer we got, actually. Right, that's the value for B. And so then you could set up your second equation. And again, use the solve command for that one, because it should work, at least in theory here. So again, the solve command is menu algebra, solve, and so we're going to take that value. I guess we don't need the B. Equals, and we set that equal to 2/3, so 2/3 to the power of x. Don't forget to put comma, the variable solved for, which is x. It gives you that, and then we're going to hit control divide, and it gives you the answer, which is 7.5. So control enter gives you that decimal, that 7.5. Really tough problem. Wow. The monster. Okay, so this one says the frequency of the data values. So I don't know if you've seen like a frequency chart. So if I were doing like set P, if I were to write that set out, it looks like there's no zeros. There's 1 1. There are 2 2s. There are 3 3s. The frequency of 3 is 3. There are 6 4s. You get the idea here. There are 5 5s. 4 and then 5. There are 4 6s. There's still all set P here. Just want you to have a visual picture of what you're thinking about. There are 3 7s. There are 3 8s. And there are 2 9s. Okay, so that is set P right there. All of that is set P, all those variables. And so it says we want to compare the mean and standard deviation. So you could add up all these numbers, divide by the number of terms. I'm not sure how many terms there are. You just have to add them up, 1, 2, 3, and find the mean. You could, if you wanted to, find the median. Have you ever done this where you do it this way? You go like cross out the biggest and smallest, second biggest and smallest, third smallest and biggest, fourth, fifth, sixth, seventh, eighth. I think you all have done this before. This one. So it looks like the median, the middle number, is 5. And again, you could do that with this data set as well. I do think once you find out how many things are in there, so 1, 2, 3, 4, 5, 6, 7, 13, 18, 22, 25, 28, 30. There are 30 items in here. Just make sure how many are in here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 18, 22, 25, 30. There are 30 items here. I don't think I counted right, did I? I must have messed that up. Although if I'm just one off there, those were both 5. So if I made a mistake, I would expect there'd be 2 numbers in the middle. I must have made a little mistake when I was writing these things out, or something. One of those, there should have been 2 numbers in the middle there. It should be the, let's see, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The 15th and 16th. Boy, I really messed up here. I think I must have missed a whole swath of folks here. So there's 0, 1, 1. Oh, there's 1, 0. So I didn't see that. There's a frequency of 1 of the zeros. So there's 1, 0. So I missed the 0. There's 1, 1, 2, 2, 3, 3, 6 4s. Ah, there's some more 4s. A 4 and a 4. It's hard to do it this way. Have you noticed that? Wow. So I missed a bunch of numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the 15th term. This is 16th. I think I would average those to get a median of 5. It still is the same median because all those numbers were about the same in the middle there. So the median would be 5. Now that I have the numbers, I can add them up and do it that way. However, there is, wow, thank goodness there's a better way. I would hope you don't have to do this for both data sets. That would be a lot of work. It's still a lot of work. I think you could do a couple different things here. So one is you could kind of look at these answers. You might be able to ballpark this. So the mean and the standard deviation of the data set P, the mean and standard deviation. So if you can tell which data set looks more spread out, boy, that's not super easy to see. Which one has the smaller mean? Now that one I think is easier to see. I don't know if you see. I'm not sure exactly what the mean is, but it's probably somewhere in this neighborhood, the 7, 8, 9. Looks like they're kind of clumped in the middle around there. Probably the mean is somewhere around 7, 8, 9, where here the mean would be, because of these numbers, the 7, the 8, and the 9 are kind of in the middle. The 3, the 4, the 5 are in the middle, and the data looks somewhat clumped around that. Maybe a little higher than that. I'm not sure if it'd be 4, 5, 6. Somewhere in that. So I can definitely tell the mean of the second set. So the mean of Q is greater, for sure. So Q has a greater mean. So what's it say? So it says the mean A and standard deviation B, I've set P. So the mean of this one is A, and the mean of the next one is C. So I think C is got to be bigger than A. So right away, I know without even figuring it out, I can see that C is bigger than A, so it's got to be one of these two things, because the mean of this guy is probably around 7, 8, or 9 instead of 3, 4, 5. So that's definitely true. Now, is the standard deviation the same, or is the second one have a larger standard deviation? Well, look at the frequency here. I think these are the same exact numbers. Do you see that? All of these numbers are the same exact frequency. And these X values are always going up by 1. I know they're different, but they're going up by 1 on the left. So I think this actually has the same exact standard deviation. The spread is exactly the same. Whatever the mean is, it's that. Now you can figure this out in your calculator. So if you want to figure this out, we can actually do this. So I'm not sure if you've done this before. Go to the list and spreadsheet. It's the icon at the bottom. It looks kind of like a list in Excel spreadsheet. Go to the top. I'm going to call it PP. Just don't call it one letter. That's why I'm calling it 2 letters. I'm going to call this QQ. If you call it one letter, it gets confused with the column that you're in, and so I don't recommend that. Actually, I'm going to make this one PP frequency, so PP FRQ, and I'm going to make this one QQ, and this one QQF frequency. So that way we can do this. Okay, so we have, I'm just going to plot these numbers, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hope I did that right. And then the frequency is 1, 1, 2, 3, 6, 5, 2. You know, I just thought about, rather than retyping that, I actually can use PP frequency for both because the frequencies are the same. We can retype that one. And this one is 4, 5, 6, 7, 8, 9, 10. Okay, so we have all the data plugged in there. And so we can go to a calculator page. Don't add a scratch pad here. You have to go to a calculator page to communicate with all that data. So you go to Menu, Statistics, one variable stat, which is in the stat calculations. So menu 611. And it says how many lists. I'm going to say one list. And for the name of the list, we're going to call the first one PP. But the frequency, we're going to call that one the PP frequency, right? So if you put the frequency in there, even though that's kind of like your second list, we call this a one list problem, and say, okay, that's going to give you two things. It's going to give you the mean is 5. So the mean of this one is 5. So mean equals 5. So that's called X bar in your calculator. You didn't know that. X with a little bar over the top of it. And then the standard deviation, which is a little sigma or sigma X on the calculator, is going to be 2.25. It's 2.25. Okay, if we redo, whoops, go back to the calculator and do this again. So menu 611, one list. We call this one QQ, and really we can actually, whoops, QQ. I'm just going to use the original frequency list because it's the same. And so this one, if you mouse up one click, you see the mean of this data is 9. And the standard deviation is 2.25, exactly the same, isn't it? If I got more decimals, it would be still 2.25, exactly the same as that one. So you can see that B is the correct answer on that one. Graph of f of x is shown, which equation defines the function f. Okay, so for this one, we've got, okay, so it doesn't give us f, but it does say this is the equation shown. So that means it moved up 1 from the original. So if this is hitting at 2, this would hit at 1. This looks like it has an asymptote at 1. I would say this one has an asymptote at 0. So y equals 0 might be that equation. It looks like that point was there at 4. It's going to be there at 3. So it's going to go through that point at 1, 3. Whoops, 1, 3. It's going to go through the point at 0, 1 as well. So if you wanted to check some of these to see which ones, I think these two are out. Those are moving them up. It should have a y there. And it's either, if you plug in 1, you should get 3. And so if you plug in 1, you get 3 with this one. So I think that would be it. You can also graph these guys in your calculator if you needed to. You can go home to and graph and type in 3tx. So that's my F4 is the name of that one. So if I wanted to, I could even hit and type in F4 of x plus 1, because it'll take that original function and move it up 1, and you can see it moves up to those points that hit there. So different ways of using the calculator. How many distinct real solutions does the equation have? So you could treat this like a quadratic. This would be the shortcut. So I'm going to call that W. So W squared plus 10W plus 25 equals 0. So we're going to try to factor that guy. W, this shouldn't be too bad. 5 and 5, plus and plus. So we get a solution of W equals -5. Now W is not really W. W is really x minus 5. So x minus 5 equals -5. So if we add 5 to both sides, we get x equals 0. Oh, wow. How many distinct solutions? Oh, wait. It doesn't say is the answer 0. It says how many solutions are there. There is one solution that is x equals 0. So there is exactly one solution. So you could graph this in your calculator. If you haven't done a lot of graphing, this may not seem natural to you, but you can actually graph this exactly like it is, I believe, and it'd be x minus 5 squared plus 10 times x minus 5 plus 25, whoops, plus 25. And don't type the equals 0, we're graphing this as a function. I think that was weird. I should have my parentheses right there. Okay, take this back. Okay. So there you see that it crosses the x-axis at 0. If you traced it, then you find 1. You can see that it's at 0, 0. That is the solution. There is only one solution. That's the only place it crosses the x-axis. So graphing, it's a pretty effective and quick way of getting how many solutions there are. What's the x-coordinate of the x-intercept of the line? So in this one, what you're trying to do is you're saying you're going to solve that one. You're plug in to find the x-intercept. If you think about it, so somewhere on here, I don't know where, is the x-intercept. All I know about that point is that the y value is going to be 0, right? So we're plugging in 0 for y. So this equation basically is 5/4 x equals 1. Solve that, multiply by the reciprocal, so x equals 5/4. So that would be your answer. There's no multiple choice here. You could also graph this, right? So if you didn't know how to do this from your project, you might remember you can graph relations. Hit the delete side, relation, type in 5/4 x plus 2/3 y equals 1. It graphs it. And so if you want the x-intercept, you should be able to trace here. So menu on 1.8. What am I doing? 5/4. Thank you for checking that. So if you multiply by the reciprocal, I didn't show my work. Multiply both sides by the reciprocal. I think I was thinking that. I did not execute that though. Those cancel, and you get 1 times the 4/5, which is, by the way, the same thing as 0.8, right? 0.8 in your calculator. It's intercept and it's 4/5. So that one. 9, again, so you might just be able to solve this one. This one's kind of tough, although those are kind of like terms. It doesn't make sense. If I give you 2 absolute values of 4 minus x's, plus 3 more absolute value of 4 minus x's, you have a total of 5 absolute value of 4 minus x's. Oops, 25. So now you're dividing by 5. You get 4 minus x equals 5 when you divide both sides by 5. Now it's a simpler problem. If you remember solving this, you want to do 4 minus x equals 5, and then 4 minus x equals, you have a choice. You could either put the negative on the right-hand side or on the left-hand side, either way you want to do it. And so this one, you would get x equals -1. That's not the one I want. This one would be -4 plus x equals 5, so x equals 9. So I think that one, we wanted the positive one. Which one's the positive? So we think that would be This is kind of a weird equation. So it says, given the equation, distinct positive real numbers, which equation correctly expresses t? So it's saying solve for t. You kind of see that if you glance at these answers. You see how they're all solved for t? We're trying to solve this equation for t. Well, it's kind of a strange move, right? Like, how do we solve an equation for t? So different ways to think through. This is r to the q equals t to the f. So kind of a weird step here, but we've done this with numbers, a little tougher with this one. You could put it to the reciprocal power of 1 over s. So this becomes r to the q over s equals, those multiply to make 1, so this is just t, and that should be it. That's pretty intense mathematics there. So if you had trouble with that, I would understand. However, I think your calculator could solve this. Let's just see what happens. So again, the solve command works with variables as well here. At least the one you can use on the SAT. The SAT, you can definitely use this. So r to the q equals t to the power of f. Now let's solve for comma t. Pretty close. So it says t equals r to the q to the power of 1 over s, which is kind of what I had there, which you multiply to get q over s. So it kind of works to do that. Sometimes the answer isn't the form we would expect, but it does work. So this one, solve this system. I might multiply everything by -1 here, so this makes it positive, negative. If you add this, you get -3x equals -1, so x equals 1/3. Maybe I should have eliminated the other one. Okay, so if I plug that back in, so this would be 6 times 1/3 minus y equals -4. So 6/3 is 2. I'm going to add the 4 over here and move the y over there. So I get 6 equals y. So I think I should get 6. Went kind of fast. Hopefully I did that right. Well, we'll find out. Okay, so you can use the solve systems command here in algebra. So if you hit menu on the calculator page, solve systems, and it says x and y, so I'm going to default to that. So 6x minus y, minus y equals -4, and 9x, and that was minus y, I believe, equals -3. Equation. You get 1/3 and 6. And so what is the value of y? Y is 6. So it does do it, and it's a little faster. So again, sometimes it might be that you don't really need to use it, but it'll be faster, so you kind of need to use it. This one is just putting everything, so it's 2/5 power. Wow, so that's kind of a weird deal here. It's got a lot going on. So wow, how do we do this? So I'm going to kind of look at the answers and see what they did. It looks like they isolated the 5 and kept it there and maybe just did something with this 2 up there. So maybe they squared it. So I'm going to forget the 5 for just a second. We'll come back to it. I'm just going to square that. So if I multiply 2 squared of x minus square root of y and squared it, so that's the top part of that fraction. So 2 squared of x minus square root of y. If I kind of FOIL that out, what do I get? First times first would be 4x, not bad. Outside would be minus 2 square root of xy. Inside would be minus 2 square root of xy. And the last would be plus y. That's not too bad. So I get 4x minus 4 square root of xy plus y. And all that's being put to the 1/5 power. I'm not sure how they wrote theirs. Is that it? Wow. So you have to kind of look at what they did. And then kind of go from there. Could you use your calculator to do that? Maybe. So you could expand. The expand command, if you haven't seen it, menu algebra. There it is. Expand. So I'm going to do 2 squared of x minus square root of y to the power of 2/5. Whoops. The power of 2/5. Let's see what that does. That gives me, oh wow. So it didn't expand it. Okay, so let me do it this way. So let me say just to the power of 2. So it will do that for me. And then it's basically saying the 1/5 power is still there, because I just did the squared part of it. So you have to be pretty creative to use the calculator, but you could use a calculator to do part of that. Almost there. I know it's a long screen time. One of the 2 equations the system is given as an infinite number solution. We should talk about, just generally speaking, what 3 options. If you have a linear system, these are all linear, you can tell that. If 2 lines cross, at 1 point, that's one solution, one real solution, they must have different slopes, so different slopes. Sometimes 2 lines do this. They have 0 real solutions, and they have the same slope. And then sometimes lines do this. And if you can imagine another line exactly coinciding on top of that, so it's really actually the same exact line on top of itself. And so that would have an infinite number of solutions. And if the slope is the same and the y-intercept is the same, here the y-intercept is different. So different y-intercept here, same y-intercept here. So this would have to have the same slope. If you remember this trick, the slope is the opposite of A over B. It's one of the most shortcuts I know. So the opposite of A would be opposite of 2 over B, which is -3. So I know the slope of this one is 2/3. So if I want it to be an infinite number of solutions, I know the slope has to be 2/3. So right away I'm going to go, okay, what's the slope of this way? Opposite of that over that. It might be that, because that slope is 2/3. That's not 2/3. That would be -2/3. Opposite of A over B is opposite of 2 over -3, which could be this one. Yes, it could. Okay, but can you tell this one's not the same equation? 2x minus 3y equals 5. I need it to be the same exact equation. This would have to be the same because those have to match. Whereas if you look at the relationship 2, 4, -3, -6, 5, 10, do you see that relationship? This is exactly twice as much. It's the same equation in this, guys. It's got to be that one. The other thing you could have done is get your calculator out, go to a graph page. It's amazing how often graphing pays off here. You have to use the relation command. So we get 2x minus 3y equals 5. If I type that in and then hit tab and type in 4x minus 6y equals 10, it should type right over the side. That red line is the black line there. So those functions coincide. They're coinciding lines. For an infinite number of solutions. Similar question with frequency here. We talked about frequency before. So to find the median, you would say how many are there? 4 plus 3 is 7, 8, 9, 14, 20. So there are 20 items. So I need the 10th and 11th would be the middle terms. The 10th and 11th term. Be right in the middle if there's 20 terms. So 4 plus 3 is 7, 8, 9, 10, 11, 12. All those terms. So that's got to be the median. The median is definitely 6 or 5 there. So the median is, or 5, I know that. The mean, how would you find the mean? So the fast way, if you don't want to use the, remember we showed you how to use the calculator to do this, so call it X bar when you do that, using menu 611. I'm just going to do it this way. So 10 times there are 4 of those 10s, plus 15, there are 3 of those, so times 3. Plus 20 times 2, plus 25 times 5, plus 30 times 6. And then I'm going to divide by the number of terms. I think it's 20. You get 43 over 2, which is 21.5. The mean, right. Median is not 5. The median is 25. That makes a lot more sense. Sorry, there are 5 25s. The median is definitely 25. Okay, so the median is 25, and the mean is 21.5, which is 3.5. The median is 3.5 greater than the mean. That's true. Median is 3.5 greater than 21.5. You know, be it. Okay, just different ways. I think we got 3. Last question, we're finally there. This is the idea of a scatter plot. We don't have the equation of this line, but it's a linear line. It'll be like some kind of y equals mx plus b. We use this line for prediction. Every point on that line is a predictive point. We're going to predict what the y value be given a certain x value. Now these red points, I'm about to make it a little brighter here. These are the actuals. So the red are the actual points, so the red are the actual points, whereas anything on the line of best fit, the prediction line, are the blue points. Every single point on that line is a predictive point. So it says, for how many of the data points does the line of best fit predict a greater y value than the actual? So where would that be? So it looks like it predicted a y, when x is 2, it predicted greater than what the red point is. Again, right there. It predicted a little bit greater than what the red point is, a little bit greater when x is 9, when x is 10, a little bit greater. So 1, 2, 3, there are 4 points. So you just have to count them. Understand what that's saying. You plug in those values, that's the predictive line there. whereas the actual points are above and below. And this line is called the residual here, this vertical line, from the actual point, which is the red point, to the point on the graph. It's called a residual. That would have a positive residual, where some of them would have a negative residual. I'm not sure if you get into that ACT, but you could. So, really long screencast, but we've covered every single problem in detail. You would expect to have a quiz on these, very similar to these problems, coming up very shortly.